Okay, guys, so today we're going to talk about 5.1. This is composite functions. So basically, a composite function is a function that is embedded within another function, or you can build it that way. Composite functions come in a lot in Calc 1 when you're dealing with the chain rule and U substitution. So this is something you definitely want to understand what it means. So I'll give you the book's definition. So it says, given two functions, f and g, the composite function denoted by f of g, or f composed with, f composed with g, is defined by this little open circle right here. That means composition of functions. Now, I prefer to write it like this. Me personally, I write it as f of g of x. And what that basically means is that g of x is going to get plugged into f. So whatever f is, g of x is going to go into it. So that's how you create a composition of functions. It says the domain, the domain of the composition of f and g is the set of all numbers x in the domain of g such that g of x is in the domain of f. So basically it's warning you, you got to be a little bit more careful. You can't just find the composition of functions and say there's the domain, because there's certain values of g that could also not be in the domain of g that might be in the domain of f. So you got to be careful with that. So let's just look at first, not to get too carried away and wordy, let's look at actually what does it mean to do a composition. So if I ask you to find f of g of 1, I would prefer to rewrite it like this. So this would be f of g of, let's find f of g of x first. So that means that I'm going to take g of x, which is 4x, and I'm going to plug it in for x. So I'm going to rewrite this. You know what, I better write it downward. I feel like I'm going to run out of room. What did we say g of x was? G of x was 4x. So that means I'm going to take 2 times 4x quantity squared minus 3. So this will become, what is that, 16? So that'd be 32x squared minus 3. So this is in fact f of g of x. So now what they're doing is they're saying find f of g of 1. So that just means I do 32 times 1 squared, right? Oops. 32 times 1 squared minus 3, which is what, 29. So that's my answer, and we're good, okay? Now, there's a faster way I could have done it. I could have just done f of g of 1 like this, but I just wanted to show you guys how to find f of g of x. So I could have just found out, well, what's g of 1? So all I do is I plug right here, I plug 1 in, and I get 4, right? So I could have just done f of 4, and then that just becomes 2 times, let's see here, what's f? 2 times 4 squared equals, and then what do we have here? Minus 3. Oops, not equals, minus 3 equals 1632 minus 3, which is 29, which is the same answer, right? There's no difference between these two. I just did this because I wanted you guys to see how I could find f of g of x real quick, okay? So let's look at this one. Okay, so we'll do it the faster way this time. So I'm going to do g of f of 1. So then g of what? So that means I'm going to take 1 and I'm going to plug it into f. So this time I'm going to go right here and plug 1 in there. So that'll be 2 times 1, which is 2, minus 3, which is negative 1. So then it becomes g of negative 1, which now I go right to here, and g of negative 1 becomes 4 times negative 1, which is negative 4. So that's my answer. So that's the faster way you can do it. If they give you a number like 1 or 2 or 3, it's much faster to plug that in, okay? And basically keep in mind what I'm doing first is I'm first finding f of 1. So I find out what f of 1 is, then I plug that number into g, and that's how you find g of f of 1, or g composed with f of 1, okay? So let's do this other one right here. So we have to do f of negative 2. So f of negative 2. But we know that f of negative 2 is going to be what? Negative 2 squared, which would be 4, times 2, which is 8, minus 3, which is 5. So this now becomes f of 5, which is 4 times 5, which is 20. That would be what f, oops, no. That's a mistake on my part. I plug that into G. We have to now plug 5 back into F again. That was my mistake. So now we take 5, and this becomes 2 times 25 minus 3, so this is 47. So that's what F of G of 2, negative 2 would be. Let's do one last one. So let's do G of negative 1, or G composed with G of negative 1. So then G of negative 1 would be negative 4, and then G of negative 4 would be, is negative 16, right? Because 4 times negative 4 is negative 16. So this is how you can do a composition of functions. It's not too crazy, but if you haven't seen it before, it is a little bit something new. So I just wanted to show that to you guys. Let's kind of go up here. Now let's look at finding domain. Yeah, okay. So now let's find the domain. So suppose I want to find the domain of F composed with G of X if F of X equals 2 over X minus 3 and G of X equals 1 over X plus 4. Okay. All right, so we have that. Now the thing is that when you're finding the domain, you got to be a little bit careful. So what we should do first is we should find the domain of G. So the domain of G. Okay, so the domain of G is X such that X cannot equal negative 4. So that means that no matter what we do, we can never plug negative 4 into this problem, because if we did, it would break G, right? So then how can we plug in negative 4 into F of G of X? Because remember, you originally have to plug into G, then whatever you get, you plug into F. So that means the domain of G has to be accounted for. But we haven't found the domain of the composition. So what we're going to do is we're going to find F of G of X. So I'm going to do F of G of X, but I know that G of X is just 1 over X plus 4. So then I'm going to take 1 over X plus 4 and I'm going to plug it in for X in F. So this will become 2 over 1 over X plus 4 minus 3. So we got to do a little bit of cleanup. So this is 3 over 1. So this needs an X plus 4. This needs an X plus 4. We want to make them same denominator so we can clean this up a little bit. So this is going to become 2 over 1 minus 3 times X plus 4 all over X plus 4. So notice I made common denominators. So now this, we'll keep going with this. So this now will become 2 over, and now this is, let's see, negative, ooh, what happened there? This is now negative 3x, that's minus 12 plus 1 minus 11, divided by, okay, x plus 4. So now let's rewrite this. This is 2 divided by negative 3x minus 11 over x plus 4. But that becomes 2 times the reciprocal, right, which would be x plus 4 over 3x minus 11. So now this becomes 2 times x plus 4 all over 3, oops, I forgot the negative there, sorry about that. Negative, I'll factor the negative out, throw it on top. So now we even have a cleaner version, negative 2x plus 4 all over 3x plus 11. Okay, hopefully I didn't make any silly mistakes. I think we're okay. Let's see, that'd be negative 3x minus 12. So plus 1, yeah, it should be good. Okay, so now, now what we have to do is we have to decide what's the domain of this guy. So this guy can also not have 3x plus 11 equals 0, because that's my denominator. So we're going to have 3x equals negative 11 divided by 3 divided by 3. So now we have x equals negative 11 over 3. So this is another value that we cannot use in this problem, right? We cannot end up with an 11/3, because if you plug 11/3 right into here, we'll get division by 0. So negative 11/3 we have to throw out. So now the domain, now we can finally talk about the domain for f composed with g of x. Finally, okay? So the domain will be x such that x cannot equal negative 11 over 3. And x cannot equal what else? We also cannot have x equal, we said, from the beginning, -4. So we have to include that. X also cannot equal -4. And that is how you find, that's like a long way to find the domain of f of g of x in this problem. Okay, so yeah, it's a little bit annoying to find the domain. You know, I'm not going to ask you to do that like 20 times, but it is important that you understand you must account for this domain, because think about it. You're always going to be plugging g of x into f. So g of x, whatever number you plug into g cannot be -4, otherwise it's undefined. But then you also have to remember that once you do all this, you can never have x equal negative 11/3, because if it does into the new composite function, that number will make it undefined. So the -4 is like from a past life of g, and this is from the current iteration of f of g of x. Okay, so this is like the old domain that you have to still account for because g is on the inner function. And this is the new domain from the new composition. So you must account for both of them. That's just how I think of it, okay? So let's see, we have another one. Let me have you guys try this one. So you should pause the video once I write this out. So it says find the domain of f composed with g of x if f of x equals 1 over x plus 2, and g of x equals square root of x plus 1. Okay, so pause the video and try to find the domain, all right? So hopefully you guys unpause the video, and the first thing you went to is square root of x plus 1. You know that this means x plus 1 must be greater than or equal to 0, right? So then x has to be greater than or equal to -1. So our domain is x such that x must be greater than or equal to -1. Okay? Now, that is for g, right? So this is for g, okay? So we're kind of set up for g now, but we know that we also have to find the composition of functions now. So we're now going to do f of g of x, or f composed with g, and this is equal to f of square root of x plus 1 under this domain that x must always be greater than or equal to -1, okay? Well, that means that we're going to have 1 over the square root of x plus 1 plus 2, okay? So if you look at this, what's the domain issues for this? So, because you guys you see all I did was I took this and I plugged it in for x, and that left me with 1 over the square root of x plus 1 plus 2. So if you want to check for domain issues, we're going to take square root of x plus 1 plus 2, and we're going to set it equal to 0. And we need to find out when this would be 0. So square root of x plus 1 equals -2, right? All I did was subtract 2. Now, when would a square root ever equal a -2? Well, the answer is never. This cannot equal because we don't accept those type of answers. So a square root can never be a negative answer, right? It can be an imaginary, but it can never be a negative, not in the way we do our math, right? That's the whole point of the principal square root. So this has no solution. Well, if it has no solution, then that means it doesn't have a number that can cause issues with the domain. So what we do then is we say our domain, we just base it off of G. The only thing that G had a problem with was X greater than -1 greater than or equal. So our final domain is X such that X is greater than or equal to -1. And that would be our answer for the domain of f of g of x. Because f of g of x itself did not have a domain issue. The domain issue comes from g. All right. So that's another problem on domain. Oops, for some reason it seems like I zoomed in too much. Hold on real quick. Okay, so let's see what else I want to talk about. So yeah, finding composite functions domains a little bit annoying. So what we can do is there's something else that this will come up in the very next section. We can show that two composite functions are equal. So we can say showing, or let's say show that f composed with g of x is equal to g composed with f of x, which equals x. This is a special type of situation. This actually means that the two functions are inverses, and that's what we'll talk about in the next section. So it's kind of good that we're leaving off with this part of it, okay? So let's say that we have f of x is equal to 3x minus 5, and let's say that g of x is equal to x plus 5 over 3, okay? So what we're gonna do is we're gonna first do f of g of x, and that's gonna be f of x plus 5 over 3, and let's see what that is, okay? So now I'm going to take x plus 5 over 3, this right here, and I'm going to plug it right in there for x, okay? So this is going to become 3 times x plus 5 over 3 minus 5. Well, the 3's will cancel, and we're left with x plus 5 minus 5 equals x. Boom, we got it equal to x. Now we got to see if it's the same the other way. Let's go g of f of x. So now I'm going to do g of f of x, but we know that f of x is 3x minus 5. And we know is that g, so now I'm going to take this guy, I'm going to plug him right there. And we know that g is 3x minus 5 plus 5 all over 3. But these cancel and become 0, and we're left with 3x over 3, but that equals x. So then we can say that f of g of x is equal to g of f of x. This means that f and g are, in fact, inverses. So this is something we'll talk about in the next section. When you compose two functions front to back, or from f to g and from g to f, and you get x exactly as your final answer both ways, that means that they are in fact inverses of each other. So this is something that we'll talk about in the next section a little more heavily. One last thing, I want you to say, suppose that f of g, f of g of x is equal to the square root of x plus 5. Okay, so if it's equal to the square root of x plus 5, let's call this h of x. I would like to know, find an f of x and g of x that makes this composition. Okay, so this is thinking backwards now. This is telling you now you already know what you end up with. You want to know where you started from. Okay, so that means I need to find an f of x and that means I need to find a g of x, right? So remember, you're going to take g of x and you're going to plug it into f of x, okay? So you have to think about what's like in your mind, what's the outer function? So to me, the outer function is f of x equals square root of x. So somebody took something and plugged it into the square root function. What did they plug into the square root function? Well, they plugged in an x plus 5, okay? So now let's see if my work will give me square root of x plus 5. So if I do f of g of x with my new versions, that means that f of x plus 5 would equal the square root. And remember, x is worth the square root of x according to my made up f of x. And I got to put x plus 5 in there for x. And I get h of x, right? So it works. But here's the thing, there's an infinite amount of answers because I could have also done this. I could have said that f of x equals the square root of x minus 1, and then g of x, I could have said equals x plus 6. So now let's do f of g of x, and now I'm going to take f of x plus 6, and I'm going to plug it into f. So this will become x plus 6 minus 1, which is equal to the square root of x plus 5, which is still h of x. So I could have written a different f of x and a different g of x. Now just think, I could do x minus 2, and then g of x would, or square root of x minus 2, and then g of x would be x plus 7. So I could play this game all day. There's an infinite amount of answers to this. But normally what they say is they want the most basic one. So this is the most basic of them. So this is how you can think about what built a composition of functions, okay? So that's something you want to work on in the homework. This is definitely a good, I assigned quite a few problems from the homework for composition, and actually just these sections overall. So please take a minute to do the homework on these after you've taken the notes, and this should really help you get a stronger foundation for 5.1. Oops, it looks like I made it way too zoomed out, but okay, you guys, that's going to do it for this quick video. Please get started on the homework. Pretty straightforward. Let me know if you have any questions.